Assalamualaikum warahmatullahi wabarakatuh. My name is Nuliana Erni binti Ahmad Karen di Iwana 0073. We're from Group A and consist of 3 members, Nur Iliana binti Muhammad and Nur Auni binti Adam. We have to go through in Experiment 4 in Lecture Relay. Before we start to build the program of Lecture Relay, we have to make sure this one is then to start. Then we insert the contact here and then we set the network to set this, and this one we can say is x0, and this one is x1, and this one is m0, and this one is m0, 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 and this one is y0 as output. And we have to make sure to the push button stop, we have to change the numeric close, Lecture Relay, and we have to compile after we finish build the program, and we click to the PLC to transfer all the data of memory. And we have to transfer all the memory until 100%. And then we click the online mode. So the PB stop, push button stop will turn on, and we click this to pause on, and all the relay and the PB and output will turn on, which is active. When we force to off, and there is no change. And if we click in the button, push button stop, we force to on, and all will be deactivated.
Assalamualaikum and hi, my name is Nur Iliana binti Muhammad Ilyas, my number C180089. So in my part, I'm going to demonstrate question 5.2, which is Latching Relay by using Isp Software. This is the question 5.2, which is have a yellow line and a robot machine. So firstly, I'm going to explain about the question 5.2. So this is the question. A sensor is placed outside the yellow line. This is the yellow line. That encloses the robot to provide safety caution to the user. If the sensor detects someone crossing the yellow line, the robot will automatically stop its operation. So by using the Isp software, I create this circuit which have a 4 network and a few push button, relay, and also a siren and sensor. So the result that I get here, I will explain later after I demonstrate using Isp. So here is the Isp software. I create a circuit. This is that I have put in this ladder program, which is in network 1. As you can see here, I put a push button with a relay 1 and 2, and also connected to relay 1. The relay 2 is normally closed. So next is for the network 2 with 1 relay 1, and also for the robot. It is for the robot machine to work as usual. So at network 3, we have a sensor with a siren stop to stop the siren, and the relay 2 and also connected with relay 2 input and output. In the network 4, we have a relay 2 that is connected to the output of siren. So now I'm going to show the compile and the run the program. Before that, I have to start the driver COM.gr. Alright, so then I have to compile, and then I can see here there are 0 error and 0 warning. So next is I'm going to click on the online mode. Click OK. And then transfer the memory remain. Wait until it 100% transfer. Alright. And then click on run. So as you can see here, the relay 2 and the siren stop is seems like on, but it is closed. Actually, it's off because we are using the normally closed in here. So all the component, button relay and other stuff in all network is now not light up. So in order to robot work as usual, which is can work as the question asked for, which is provide safety caution to the user, and the sensor will detect someone crossing the yellow line. So firstly, we have to click on a push button, which is force on. And as you can see here, while the push button is force on, then the relay 1 and the robot will be turned on. This is because the robot will work as the push button is forced to on. So, how to detect if someone crossed the yellow line? For example, in the network tree, we have a sensor 1, so click force on. So you can see here, while the push button is on, the robot will be automatically stop the process, the operation, if the sensor is detect someone crossing the yellow line. And you can see here also, in network 4, the siren will be turned on, which is or relay 2 also will be turned on. So, in order to make a robot operate as usual, back as usual, so you have to force off, and this one also be force on. The siren will stop and the push button on, the robot will automatically operate as usual. Now back to the presentation in slide. So we have the results from the operation in Isp Software. So this is the first result, which is if we turn the push button on and the robot will be start to work. As for the relay 2, M2 and the siren will stop X3 seems on just because they are set to be normally closed. So in operation 2, while the push button is on, we want the sensor to detect if someone crossing the yellow line. So if we force on, then the siren will be turned on, and also the relay 2 in all network 3 and network 4 will be on, while the robot will be automatically stopped. So in order to have a robot to work as operation as usual, so just force off at the siren stop, and then the siren will stop and the robot will be automatically on as usual.
Hi, Assalamualaikum warahmatullahi wabarakatuh, and hello to everyone. My name is Nurauni binti Adam and my matrix number is AE180055. So today I would like to present about the 5.3, the solution. So as here you can see, this is the data IP solved. So I need to, this one I already assembled it, and this is the sensor 1, sensor 2, and this is M1, which is relay 1, and this is relay 1 also, and this is for the network 2. We have a relay 1 and garage door. So at here, how we need to do this as normally open or normally close, we just double click, and then already this one we can choose. So this one is normally closed, so that's why I use normally closed. And then after that, I need to compile. So we click compile. So at here you can see the total memory and memory remain, and it was a 0 errors and 0 warning. And then we do the tools, communication setting, and then we choose the driver. And then from at here you can see at bottom the com, and then we already start. So after that we do a run, and then we do the online compile. So at here you can see when the sensor 1, which is X1, is we put as on, the sensor 2 will be off, and then the another part of them is off. But when the sensor 2 is we put as off, so all of the relay and the garage door will be open, will be on. So this is the how we assemble for the 5.3. So we are back with the result from 5.3. So this is the table that we get for design 5.3. So when the sensor 1 and sensor 2 is 0, which is turned off, the relay 1, relay and the garage door will be 0, and which is means off. But when the sensor 1 is 0, turned off, but sensor 2 is on, the relay and the garage door also 0. And when the sensor 1 is 1 and sensor 2 is 0, so the relay and the garage door will be on, because from this design system there are two networks that created in Delta Isp Soft. In network 1 has sensor 1 X1, sensor 2 X2, relay 1 M1, which is in parallel and series. Meanwhile for network 2 has relay 1 M1 and garage door Y1. As we could observe from the design, when we run with the sensor 1 X1 is off and sensor 2 X2 is on at figure 1 like this, the relay 1 and garage door will on. This is because when sensor 2 X2 forced to be off, it will be turned green, which means it inversely with the input. Furthermore, sensor 2 X2 is normally closed. However, when the sensor 1 X1 is on and the sensor 2 X2 is on, the relay 1 and garage door will be off. This will show in figure 2 as you can see at here.
For question 6.0, we have to build a one conveyor in Apple packaging, and then in a first operator, sensor 1 is a contact, we detect the presence of apple. The apple will fall into the box one by one. After 10 apples have been counted by sensor 1, here we have to use a counter ladder program. In apple conveyor we stop and it's ready to pick up by the operator. We use a latching relay to design our program. This is our program. Okay, Apple conveyor using a latching relay and counter ladder program. In a network 1, we have push button start, which is XO. We have a push button stop. X1 is normally closed. Relay as a MO, M0. And then in network 2, we have a relay that connected from the network 1. And we have a bulk conveyor as a Y1 and Apple conveyor as a Y0. This is the output. Okay. And then at the network 3, we have a sensor 1 and a sensor 2 as a normally closed, and we have the counter that count in a 10 apple here. And we have a sensor as a S2, normally closed. Okay, we have to run this one. We have to run this program and make sure the configure is start, right? Okay, before this we have to compile, and then we have to click the PLC and transfer all the data of memory. Click transfer and make sure we have a 100% is ready to transfer. And we have to click close after the finish, and we have to click the online mode. We can see here the push button start we already in green light, and push button stop is ready is green light. Board conveyor is ready and sensor 2 is ready in a green light. And then we click run. We can see all the relay and the box already is ready. And make sure before we close we have to off the push button start, and then we start to count in 10 apple to insert in the box, and then we start to count. Okay, we have to insert one by one apple at the box. Set on. Okay, we can see here the C0 will count 1 if we on off the button of the sensor, and then we set off and we set on again, it will count 2. So we set on off until 10. Okay, we can see here we have finished count 10 apple inside the box. Okay, the box conveyor will turn on. They already finished in 10 apple inside the box, and we have to count again, and will be next another box to insert a 10 apple. That's all from me. Thank you.
So, as for the discussion, in Lab 4, we have been given 3 latching relay exercises that are required to construct circuits with relays, push button, and sensors. Firstly, we're doing basic ladder program as previous lab experiment, but this time with push button, start and stop, and also a few relays. In the exercise 5.2, we have learned to design a program using latching relay for a robot that provides safety cautions. There are 4 networks in total, which a sensor is used in network 3 to detect someone crossing the yellow line, and then include a siren which will be turned on during the detection of someone, and all the operation of robot will be automatically stopped. Furthermore, we are also designed an automatic system for home garage with using a sensor that will detect existing of car, and S2 detect car is safely parked in garage. So lastly, we has been designed a program by using latching relay for Apple packaging. All the results and the observation of the design has been completely done through each exercise given successfully.
So next and the last is the conclusion for this lab. So as we complete the design and task in this lab Mrib 4 latching relay, we achieve the outcomes which are familiar to the techniques to program PLC using programming Isp Software, counter and timer, and building up simple programs, run and troubleshooting. From the demonstration and the result, we could learn the behavior of the contact which is normally closed or normally open. Also, we could design the PLC based on the situation given. That's all from us. Thank you.